So we have seen first that the vibrations are caused simply because of the mass and elastic property of objects or the particles. Then there is one very peculiar nature of these kind of oscillatory motion. It is called as a periodicity. So if we remember periodicity, right, it is the movement and the displacement of the object repeats again and again after a specific amount of time. So that time is referred as the periodicity, right? Then we had the various types of vibrations. So the types of vibrations are, first one is a free vibration, second is damped, then the third technique is called as, right, the forced vibration. So free vibration is basically body is going to vibrate at its natural frequency, no force on the body, right? Whenever you leave the body free, it oscillates, right, at a natural frequency without any force on that, right? And its amplitude is not going to decrease even after leaving the body as it is for a long time. Its amplitude remains constant. So such vibration is called as free vibration, and the characteristic of free vibration is that there will be a restoring force that is proportional to its displacement. In a sense, when an object moves from one side to other side, there is a restoring force to bring it back. That is the basic nature of the free vibration. So let us look at the mathematical view of the same thing. So we assume that there is a mass m and you have a restoring force that is F. So this restoring force is negative of, right, minus mu into y, where y is the displacement. Whatever is the displacement, that is y, it is actually it decides what is the force on that object, and minus sign is given just to make sure that it is opposite in the direction, and mu is the coefficient. So we can see that mu is a proportionality constant. Y is the axis of vibration in which how much is the displacement along that axis, right? So as mentioned, negative sign indicates the restoring force is opposite to the direction of displacement. Now first we write the force required, right? That is, force is equal to mass into acceleration, right? Acceleration can be directly obtained by differentiating the displacement twice. So if y is the displacement, d square y by dt square will be the acceleration. So F is equal to m into d square y by dt square is the required term. But we know that both the forces have to be same because both forces are acting on the same body. So left hand side we'll write one of the equation, that is m d square y by dt square, and on the right hand side we'll write is equal to mu into y. So both terms, in order to make the second order differential term without any coefficient or coefficient equal to 1, we'll divide the whole equation by m. So what we do, we write d square y by dt square is equal to minus omega square into y, right? And now because of this, you can see that when I take the minus omega square y to the other side, I'm going to get d square y by dt square is equal to d square y by dt square plus omega square y is equal to 0. Let's call this equation 3, but if you look carefully, this is a second order homogeneous differential equation. So if you have a differential equation, right, we know how to solve it. So we'll apply the same steps. First you guess a root. So you guess a solution. The solution will be in the following form, that's given by equation number 4. Always, if it is homogeneous second order, we are expecting y is e to the power alpha t, where alpha is a root of the characteristic equation. So using that, now our intention is to use this equation in the main equation, that is equation number 3. But equation number 3 uses d square y by dt square. So I am supposed to find out what value is that. So what we do, we differentiate and get the equation. So y is e to the alpha t, differentiate twice. When you get d square y by dt square from dy by dt, you have alpha square e to the power alpha t. Let's say that is equation number 5. So put 5 in 3. So we are going to get alpha square e to the alpha t plus omega square e to the alpha t equal to 0. I can see that e to the alpha t is common. I'm taking it out, and e to the alpha t into alpha square plus omega square is 0, which means e to the alpha t is not an answer, not equal to, cannot be equal to 0, because e to the power something. This means the other term has to be equal to 0. So we equate alpha square plus omega square equals to 0. So alpha square is equal to minus of omega square, right? So alpha becomes equal to imaginary, right, plus or minus j omega, right? When alpha is that, we can write a solution, because there are two roots now. Alpha is plus j omega, alpha is minus j omega. So we'll write a solution in the following notation, and that is a1 e to the j omega t plus a2 e to the minus j omega t. We call this as equation number 6. Okay, then let's say a1 and a2 are the constants, right? Now I can see that e to the j theta in the equation number 6. So we use the identity that is used from the complex numbers chapter in mathematics. So y is equal to, we write e to the j theta as cos and j sine with a positive sign in between. If you have e to the minus j theta, you can write it as cos theta minus j sine theta. Okay, now in the next step, let's do y is equal to a1 into cos omega t plus j sine omega t, right? So that's first term, plus a2 into cos omega t minus j sine omega t. Now this will be equal to, we try to take the coefficients of cos together. So that is a1 plus a2 multiplied by cos omega t, which is the first term, plus j. We'll take out the sine coefficients of sine and the j, which becomes a1 minus a2. Now, in order to simplify further, we call the term a1 plus a2 as capital A sine theta, sine phi, and j times a1 minus a2 as a into cos phi. Okay, now so that we can update the equation as y is equal to a sine phi cos omega t plus a cos phi into sine omega t. Now another trigonometric identity is there. This is called as sine of a plus b. If I have two angles inside, right, and I want to take the sum of them, and then I want to take the sine value of that, then I can individually, using the sine and cosine values of the two angles, I can calculate. So that is sine of a plus b is sine a cos b plus cos a sine b. Right. So using that equation, I can write y is equal to a into sine of omega t plus phi. So this is the solution of the equation, differential equation, which we started with. Now here the amplitude is capital A, which says that it is the maximum amount of displacement possible by this object. Then we have next term, that is omega, which we already have defined. T is the time and phi is called as the angle, right, that corresponds to lead or lag angle. Okay, now in order to find the period of oscillation, we will assume that the value of this function is again calculated at t is equal to t plus 2 pi by omega. So we repeat at this the measurement of the same function at a different value. So what happens now? So since it is t is replaced by t plus 2 pi by omega, so a becomes equal to sine omega t plus 2 pi plus phi. So that means capital A sine omega t plus phi. So originally y was the same. Even after changing the t to a different value, right, we still get the same answer, which indicates that, right, so it is periodic. And that time which you increased, right, that is called as 2 pi by omega. This is called as the period of vibration. Okay, so that is the first type of the vibration, and now we go for the second type of vibration. This is called as damped vibration. Now whenever a body executes the vibration, right, we expect that the amplitude of that kind of vibration keeps on decreasing. This is because whatever is the medium surrounded by the object, it has a resistance, it offers a resistance to the movement of the body, and also there will be friction associated with the movement of the body. So because of these two properties, we always have reduction in the amplitude as the time progresses. So what are the different types of forces acting on this? We can see that there are two types of forces acting on the body, which is going to have the damped oscillation or damped vibration. So that is, see, first thing is there is a force which was already existing. It is a restoring force. So F1 is equal to minus mu into y. That's an obvious question, like obvious point, like the previous case. But now the additional part that comes in the damped oscillation is that it is called as a damping force. So the damping force acting on the body is proportional to the velocity of the object which is moving, and it is directed oppositely to that force. That means it's going to act in a direction opposite to the required direction. Okay, so that means now we can write F is equal to, normal equation is F is equal to m into a, which is d square y by dt square. But now this force needs to be equal to the sum of other two. What are they? One is minus mu into y, and the other one is minus r into dy by dt. So r is the proportionality constant, and the other constant will be mu. See, on the right hand side we have negative. The terms are denoted by negative sign. It is just to indicate that the forces are actually opposite to that of m into d square y by dt square. Okay. Now what we do, we'll take the negative terms to the left side to make it positive. So that means m into d square y by dt square plus mu into y plus r dy by dt is equal to 0. Everything you move from right to left, so nothing is present on the right side. In the next step, I divide the equation by m. So I get d square y by dt square plus r by m into dy by dt is equal to mu by m into y. Once again, if we look at this equation carefully, we understand that this equation is a second order differential equation, and the second order differential equation always, right, can be solved, right, using the standard method, right. So what we do, we directly write its possible solution. The second order differential equations format will be always like y is equal to e to the power alpha t, which is equation number 2. Okay, but in order to substitute this back in the equation, I need dy by dt, which can be calculated as, right, alpha into e to the alpha t. Then d square y by dt square is alpha square into e to the power alpha t. So that is what is equation number 3. So overall we substitute every value we got just now into this equation. So that is a alpha square plus or minus the j. So we'll write it in this way, right? So e to the alpha t alpha square plus 2 times bt plus b alpha plus omega square. So since the e to the alpha t cannot be equal to 0, we have to have this function to be equal to 0, which is the alpha square plus 2b omega plus alpha square. So equating that to be, whenever you equate to 0, you get alpha square equal to, what is the root? Right? It's nothing but alpha square is there. That is alpha square is having roots. So root of, so this is minus b plus or minus b square minus omega square. Okay. Then we write the equation for alpha. Then we write the equation for omega. So omega is equal to, sorry, alpha is equal to minus b plus or minus root of b square minus omega square. So substituting that once again in the given expression, we have a1 into e to the power alpha t. So a1 into e to the power the same number. And the second number becomes a2 into e to the power, right, same term with the minus sign. So root of minus b square plus b square omega square. So that's the term we are writing. So in this case, you can see that there are several cases. The cases are something like when the equation becomes, when the value is the b square is greater than omega square. So whenever that condition is satisfied, you can see that the term b square minus omega square is a real quantity. Okay, so whenever it is real, right, we call that case as overdamping. Then we have a next case which is b square is less than omega square. So the term b square minus omega square under root in the equation format, it becomes equal to root of omega square minus b square, and j is equal to root of -1. So a1 into, instead of 1 multiplier with the exponential of minus bt and exponential of minus bt, we are multiplying with the e to the power jbt. So what is that? That function is, that is equal to e to the power. So a1 into e to the power minus b plus jbt plus a2 into e to the power minus b plus jb1 into t. So next we have, which we will take e to the power 6 on one side, e to the power minus bt on one side, and e to the power minus bt, which is common on both sides, we'll take it common. So you can see that e to the power, that is exponential of minus bt into, write the remaining terms, a1, we can write it as a1 cos bt plus sin j sin bt, and we have a2 into a2 into cos bt minus j sin bt. So this is equal to e to the power sine of, we can rewrite it, alright, so that becomes equal to exponential a sin phi cos bt plus a cos phi into sin bt. So you can see that this is sin a cos b cos a sin b format. So we can take out the common terms and we can write it as a into sine of root of omega square minus beta square under root. Alright, next, here the capital A is a into e to the minus bt. So that is called as the amplitude of, okay. Next, we, let's take the third case, omega square and the beta square. Next we have b square and omega square are equal. This particular condition is called as, so b square is equal to omega square means that is equal to 0. Okay, right. So what we do here now is we'll write the equation, that is y is equal to e to the minus bt, a1 e to the power ht plus a2 into e to the power minus ht, right? So now we'll call the h value, right, as a characteristics. If you call h is equal to root of b square minus b square minus, the solution can be directly written, but so it becomes y is equal to e to the minus bt into p1 plus qt. So where p is the sum of those two and q is, it's a difference. Then we looked at the attenuation coefficient or a constant of the vibration. Okay, so to calculate the attenuation constant, wow, cool. So this is what is attenuation? So characteristics of, so there are three basic parameters to decide the attenuation constant. First one is a log decrement. If you have, say, capital A is equal to A into e to the minus bt, right, then the b is called as the damping factor. Right. Now, say A0, A1, A2, A3, etc. are the different various amplitudes of the object at different intervals of time, say T1, T2, and T3, etc. So you can call it as T2, T3, T4, T, etc. also. Right. Now, if you take the ratios like A0 by A1, A1 by A2, so what we do now, we call the lambda as bt, which is the logarithmic decrement. So once we take the natural log on both sides, the lambda is equal to ln natural log of given answer. So which is also same as a2 by a1. Next one is relaxation time. So the relaxation time is defined as the given time instant, right? We know that the total energy of a damped oscillator will remain same. So how much time it takes between the as the relaxation is the relaxation time. So first we calculate the energy is equal to half of mu into a square. So the a square is defined as a minus a into e to the power minus b. Right. So this becomes after the substitution e naught into e to the power minus 2 into beta t, because half of u into a square. Okay. Now that's what we call as equation number 2. Right. Now the relaxation time is 1 by e times the third times. This means in order to find a tau, let us equate both the equations. One is E naught by E, second one is 2. All right. So after equating those terms, now we get equal to this value. Okay. So E is equal to E naught into e to the 2 beta t. And then once we equate for relaxation time, we get tau is equal to 1 divided by 2b. So E is equal to E naught into e to the power minus t by tau, with the tau value as 1 by 2 bt with the minus. Right. And the third technique is called as the quality factor. So the quality factor is nothing but we have to use a ratio to calculate that. That is 2 pi into the total energy stored in a system divided by the energy lost in one period of the system. So the energy stored is the complete duration. Energy lost is uh, for only one period of one cycle. So now let's write the equation, which is 2 pi into E by 2p. Okay, therefore, now this is equal to, we have a Q value and use the Q value to calculate this like this. So as we know already, the Q value is 2 pi into E by P into T. So there is a power dissipated is P over a time period is T. So we will be using this particular equation. So P is equal to dE by dt. Apply the dE by dt to E naught into e to the power minus 2 into dt, right? So that gives you E naught is minus 2b into e to the minus 2 bt. So total power P is minus 2b into e. So what we do, we can calculate the Q value now, that is 2 pi into capital E whole divided by 2b into e into t. So e cancels, 2 and 2 will also cancel, it's just right, the term is omega divided by 2b, because 2 pi by t is omega. I can actually substitute even in that way, which is also equal to omega times tau, right? Then we go for the third type of oscillations. It is called as the forced oscillation. So we can see that here, the in a damped oscillation, as the time progresses, we lose the energy, right? And the loss of this energy in a damped oscillator can be compensated provided externally you apply a periodic force. That force should compensate the loss of energy that is occurring in a damped oscillation. In each oscillation, there is loss of energy. So once you do that, we can observe that the vibrations are sustained. Vibrations remain for a long time. So because of that, now vibrations uh, can be sustained means, right, there has to be an external force and the frequency of oscillation should be decided by the external force applied, not by the internal or not by the system itself. So there is a condition like this which needs to be satisfied. Okay, now let us do the analysis. So to start with, the analysis begins in this way. The body is acted upon by normally three types of forces. One is a restoring. We know that it is given by F is equal to minus mu into Y. And there is another force, that is damping force, proportional to the velocity and minus in direction. So we can call it as F is equal to minus R into dy by dt. Then there is an external force represented by F sine Pt, right? And there will be a frequency of that given by P by 2 pi, right? So total force we can write as m d square y by dt square is equal to minus mu y minus r dy by dt plus F sine Pt. Now, as a result of this, the equation can be simplified as d square y by dt square plus r by m plus dy r by m dy by dt plus mu by m into y is equal to f by m into sine of pt. So r by m becomes equal to 2b, mu by m becomes equal to omega square, and f by m becomes equal to f. We already have used this several times. So what we do, we put them as equation 4 and we use 4 in the equation number 3 to get equation number 5. Right, and we assume the solution of this fifth equation as following. So it is y is equal to a into sine of pt minus theta. So here a is the amplitude, that's the steady amplitude with which it oscillates, and theta is the lag angle. Right, now let's find the dy by dt and d square y by dt square. Right, as you can see, they are straightforward. Dy by dt is a into p into cos pt minus theta, and the d square y by dt square is straightforward, minus a p square sine of pt minus theta. So once we have this, use these two values in fifth equation to get the following. So minus a p square sine pt minus theta plus 2b into ap cos pt minus theta plus omega square a sine of pt minus theta is equal to f sine of pt. This is equal to f into sine of pt minus theta plus theta. So a plus b. If you call this in the a plus b format, we can try to write the following equation. So a into omega square minus p square into sine of pt minus theta. I'm trying to take out equating the sine terms, coefficient of sine on both sides and coefficient of cos on both sides. So we can get the two equations which are equal, right? And we are going to call them as equation number 8 and 9. Then we square the two terms to add and we get the value of a, and tan theta can be obtained by dividing equation number by 8. So a and theta are as follows. So now we look into some special cases. If p is less than omega, we can prove that amplitude is f by mu and theta is 0. At the same time, if you get a value is equal to if you can consider the case there, the p is much greater than the omega, external force has much larger frequency compared to omega, a is equal to f by root of omega square minus p square whole square plus 4b square p square. So in which we make an approximation that p is much bigger than omega. So minus p square whole square is p to the 4 and rest of the terms are smaller than this. So simply you can approximate f by p square. Theta is negative minus, it's a 0 but negative value, closer to 0 on the negative side. So you can say that it is pi, 180 degrees. And if they are equal, right, we get a very special case called resonance. Then the concept of resonance was discussed, in which we define that the whole process of resonance is nothing but a body is made to vibrate with maximum amplitude under influence of an external force by making the frequencies of applied force and the force which is acting upon that, right, you make both of them equal. Okay, under this condition, if you make a body to vibrate, it is called as resonance, and resonance is seen in LCR circuit, right? So we saw the series LCR circuit as an example. So we consider a LCR circuit. L is a inductance, C is a capacitance, R is a resistance. So it is supplied by a voltage source denoted by V, and VL is the voltage across inductor, VC is the voltage across capacitor, R is the voltage across resistor. Right. So then we wrote the values of VC, VL and VR. Those are equation number 2, 3 and 4. Then we applied KVL in the clockwise direction starting from the power supply. So V minus VL minus VC minus VR became equal to 0. So as you can see, once we have this equation, we substitute the values and we get equation number 5. Comparing this equation 5 with the original equation of vibration obtained in the mechanical or physical system, we can compare and get the equivalent terms when it comes to the mechanical oscillator and the electrical oscillator. So displacement is equivalent to charge in electrical system, mass in a mechanical system is equal to inductance, and so on. You can see that velocity and currents are right equivalent, right? Damping factor small r is equal to resistance capital R in the electrical circuit. The force constant mu is very much similar to 1 by capacitance of electrical network, and force is equal to the velocity, sorry, voltage. Force on the left hand side is equal to voltage on the right hand side, so denoted by V naught. So what we do, we equate the required terms and get the required quantity, such as say F, force. It was originally force in the capital F, but when it comes to the electrical system, F is the frequency. So you can see omega by 2 pi was a natural frequency which was equated to 1 by root LC, right? Omega is 2 pi F. So this F is 1 by 2 pi root LC is the frequency of oscillation. Then quality factor can be proved that 1 by R into root of L by C, right? Then we calculated the amplitude of oscillation by using the f by n, which is root of omega square minus b square whole square plus 4b by b square p square. So converting this into the required electrical format, you can see that v naught by L root of 1 by this LC minus p square whole square plus r by L whole square into p square. So inductive reactance is what is XL, P into L, or XC is 1 by PC. So equate them. So XC by XL can be obtained as 1 by P square into LC. So LC means take P square to other side, XC by XL you make, right? So we already know that R by L whole square is, right? L can be written as XL by P whole square. So right, obtain these values and substitute in the Q naught value and you get, right, the equation which is like this. So V naught divided by P times this value. So move P to the other side. So P into Q naught is what? It's nothing but current. So that is 2 pi F into Q. Oh, is that. So variation of the Q is current. So I naught is this equation. So see that this is the impedance. Now, if you want to bring the resonance in the circuit, the frequency P should be equal to omega. So omega is 1 by root LC. Equate P with that. So I can see that P and P getting cancelled and I'm left with the root of LC. Root of XL by XC is 1, which means XL by XC is equal to 1. So that is the condition. XL equal to XC is the required condition for resonance of a circuit. So, and using the same thing, we can actually find the maximum current, because when you have a resonance, current becomes maximum in a series LCR. So simply we'll calculate I max is equal to V naught by R, right? This is the whole theory part of the process, and we can use it to use it in various applications.